Hello students, welcome to the 50th class in linear algebra. In this video lecture, we will discuss a very important topic, that is an invariant subspace. So let me to take the definition of invariant subspace first of all. So in order to define the invariant subspace, I will consider a linear transformation. So let T be a linear transformation which is defined from, that is V to V, that is a linear operator, right? So this is any linear transformation, and now I consider U to be any subspace of V. Then when can I call this U invariant? Then U is said to be invariant under T. So if and only if for all U coming from capital U implies T of U also belongs to capital U. So if this condition holds, then I say that this capital U, which is subspace, this is a special kind of subspace known as a invariant subspace. Now let me to consider two very basic examples so as to make you these things clear. So the first example is, prove that the range space of a linear transformation T, that is a linear operator defined from V to V, is invariant subspace under T, right? So let us check how to show this subspace is a invariant subspace. Clearly you all guys know that range is always a subspace. You can check it out. So how can I define the range of a T? So range of T is defined as, generally denoted as capital R of T. It is the collection of all the W's, right? Clear? Such that, what is this W? This W is nothing but T of V, for all V coming from capital V. So that is the collection of all the images, right? Now because we know that range of T is a subspace, already proved in the previous video lectures, link added in the description. Since range of T is a subspace, therefore this W will belongs to capital R of T. And what is the R of T? So T is a map which is defined from V to V. So what is R of T? That is a V only, right? So W belongs to capital V. So by the definition of linear transformation, T of W belongs to the range of T. So in the beginning we considered W belongs to range space of T, and finally what I proved that T of W also belongs to the range space of T. So that is the definition of an invariant subspace. You can look into it again. So if I consider U to be any subspace, I will call this U as invariant if you consider any arbitrary element. For all U coming from capital U, T of U should also belongs to U. So W was any arbitrary element, right, that was belonging to R of T, and finally you proved that T of W also belongs to the R of T, and hence I can say this implies range space of T is an invariant subspace. So in the next example, let us check whether the null space is an invariant subspace or not, right? So first of all, let me to define what is the null space of T. So the null space of T, generally denoted as capital N of T. So what is that? That is the collection of all the vectors. And what is the condition on these vectors? So the vectors, they are coming from capital V, such that if you apply T on V, it will get mapped to 0. So now let me consider any arbitrary element V coming from null space of T, right? So what does it imply? If any vector belong to the null space of T, so it implies T of V should be 0. So that is by the definition of null space. Now since T is a linear transformation, and we have already proved in the previous video lectures that T of 0 goes to 0. So now if I apply T on both sides, right, and what is T of 0? So this is 0. Fine with this? So can I say, just try to understand this point now, T of anything is going to 0, right? So T of anything is going to 0. So what does this mean? This means this anything belongs to the null space of T. Yes or no? So can I say T of V belongs to null space of T by the definition of null space? Fine. So in the beginning you considered V to be any vector coming from n of t, and finally you proved that t of v also belongs to the n of t. So finally what do I say? So that v belongs to n of t implies t of v belongs to n of t. Therefore we can say that the null space of t is invariant, right, under t. So that is how you can prove any subspace to be invariant. So I hope this video lecture is clear to you now. In case if you have any difficulty, you can mention your doubts in the comment section. For more such videos, do subscribe to our YouTube channel and do not forget to press the bell icon. Thank you so much, students. Thank you.